Stone giants like Chartres Cathedral are not just artistic triumphs, but complex mathematical equations carved in stone. This video will unlock the hidden codes embedded in the sacred architecture of the ancient world, revealing how medieval builders used geometry, proportion, and number theory to create structures of profound spiritual and scientific power. We will journey from European cathedrals to Eastern temples, uncovering secrets encoded for centuries. You will learn to see these ancient wonders in a completely new light, discovering the universal language of mathematics that connects humanity across time. How did builders without modern tools weave cosmic truths into their designs? What secret numbers give a Gothic vault its timeless harmony? By the end, you will possess the keys to decipher the silent sermons written in stone, understanding how these ancient principles still shape our world. What forgotten truths do you think are hidden in plain sight around us? A single circle drawn in the sand held the entire cosmos for these master builders. This was the starting point, the fundamental alphabet for a language written not in words, but in form and space. They saw geometry as sacred, a direct reflection of the divine order governing the universe. Simple shapes like the circle, square, and triangle were far more than practical tools. The circle represented heaven, unity, and the infinite divine. The square symbolized the solid, manifest earth, and the triangle, pointing ever upward, signified the ascent of the human spirit toward the celestial. Together, they formed a visual vocabulary for expressing the relationship between the material world and the spiritual realm. From this foundational alphabet, they constructed more complex sentences. One of the most powerful and recurring symbols was the Vesica Piscis. Imagine two circles of the exact same size overlapping so that the edge of each one passes through the center of the other. The almond-shaped area where they intersect is the Vesica Piscis. This was not just a pleasing form. It was seen as a generative womb, the very shape from which creation emerges. You can find this pattern at the heart of countless medieval rose windows, its elegant curves framing stained glass that pours colored light into a cathedral's nave. It also forms the basis of the seed of life, a pattern of interlocking circles that unfolds into a blueprint for all of existence, a pattern repeated in temple floors across continents. As historian Robert Lawler expressed, this sacred geometry was a mirror of the universe. It reflected the same patterns found in a snowflake, a honeycomb, or the spiraling arms of a galaxy. The architects were not inventing these shapes, they were copying them from the grand design of nature itself. This profound belief drove them to align their temples with the movements of the heavens. A church might be oriented so the rising sun on the feast day of its patron saint would shine directly down the main aisle, bathing the altar in light. In this way, the building became a microcosm, a miniature heaven on earth where the cosmic dance of the sun, moon, and stars was mirrored in stone and glass. This deep, symbolic understanding of form was only the first step. It was the philosophical bedrock upon which they built something even more precise, a system of invisible numbers and ratios that would give their structures a harmony so perfect it could be felt in the human soul. What were these secret numbers, and how did they weave them so seamlessly into their monumental works? This pursuit of perfect proportion found its ultimate expression in a single, remarkable number. Known as the golden ratio, this mathematical constant, approximately 1.618, was considered the key to divine beauty. The Roman architect Vitruvian, whose writings were a sacred text for medieval masons, argued that buildings must imitate the proportions of the human body, a form perfectly shaped by nature itself. He believed this harmony was what made a structure truly pleasing to both the eye and the soul. The master builders took this idea and encoded it into their stonework, seeking to replicate the same perfection they saw in a nautilus shell or the spiral of a sunflower. This ratio, often represented by the Greek letter phi, appears where you might least expect it. Look at the floor plan of Chartres Cathedral. The ratio of the length of the nave to the width of the transept often aligns almost perfectly with phi. This was no accident. It was a deliberate act of mathematical worship. But how do you generate this elusive number? The answer lies in a simple sequence of numbers discovered by the mathematician Fibonacci. Start with 0 and 1, then add the last two numbers to get the next. So you get 0, 1, 1, 2, 3, 5, 8, 13, and so on. As this sequence grows, the ratio between successive numbers gets closer and closer to the golden ratio. This sequence manifests as a spiral, a shape you can overlay onto the very facade of a cathedral, and watch as its curve gracefully traces the rise of arches and the flow of sculptural elements. This was more than an artistic choice, it was a spiritual endeavor. By weaving the golden ratio into their work, the masons were connecting their creation to the fundamental pattern of life itself. Yet this divine proportion was not the only sacred number guiding their hands. Another, more dynamic and potent constant was also at work, one that would unlock the very geometry of growth and stability. While the golden ratio sings a melody of organic growth, another number provided the fundamental bass note of stability. The square root of 2, approximately 1.414, was the master key for transforming a perfect square into something dynamic and expansive. This irrational number, which cannot be expressed as a neat fraction, emerges from a simple yet profound act, drawing the diagonal across a square. The moment you connect opposite corners, you have created a new length, the diagonal, that relates to the original side by this exact ratio of 1 to the square root of 2. For the medieval mind, this was a moment of cosmic significance. It represented the first step out of the unity of the one, the square, into the multiplicity of the manifest world. This ratio became the geometric engine for generating entire floor plans. Imagine a rectangle where the shorter side is 1 unit and the longer side is the square root of 2. The true magic of this shape is its self-replicating nature. If you divide it in half along its longest side, you create 2 smaller rectangles, each one possessing the exact same 1 to root 2 proportions as the original. You can keep dividing these smaller rectangles again and again forever, and each new shape will be a perfect proportional copy of the first. This created a visual rhythm of balanced, echoing forms, a fractal harmony built right into the stone. You can witness this silent mathematics in the grounded spaces of a medieval abbey. The chapter house, where monks gathered for daily meetings, was often designed using this precise ratio. Its rectangular footprint, governed by the root 2 proportion, would foster an atmosphere of deep, structured order. The same principle applied to the design of altars and the serene walkways of cloisters, where every arch and bay felt perfectly in tune with the whole. Why would builders be so drawn to a number that is inherently messy and infinite? Precisely because it was irrational. Its decimal digits go on forever without repeating, defying complete human comprehension. This made it a perfect symbol for the inexpressible, infinite nature of the divine, a number that pointed toward a mystery far greater than itself. By building with the square root of 2, the masons were not just constructing walls, they were encoding the very concept of stability through dynamic growth, a stability that could unfold into infinity. But what happens when you combine these sacred numbers, when the stability of the root meets the growth of phi? The result is a symphony in stone, a complex harmony that gave rise to the most breathtaking structures ever built. These sacred numbers found their echo not in silence but in music, the same mathematical ratios that gave a structure its visual stability were believed to produce the most beautiful harmonies to the ear. Medieval scholars called this concept Musica Universalis, the music of the spheres, a celestial symphony created by the mathematical movements of the planets, a perfect harmony that only the soul could hear. They were convinced that the divine order was not just seen but also heard, and that a truly sacred building should resonate with this cosmic song. The philosopher Boethius, whose works were essential reading for every educated master builder, divided music into 3 levels. There was the music made by instruments, the music of the human body and spirit, and finally, this highest music of the cosmos itself. The architect's monumental task was to make this highest, inaudible music visible and tangible in stone. They achieved this by translating musical intervals directly into physical space. Think of the simplest and most perfect harmony, the octave. On a string instrument, if you press the string exactly halfway, its length is halved and the pitch jumps a full octave. This creates the ratio of 2:1. Now, look at the Grand Duomo in Florence. The relationship between the immense width of its nave and the height of its majestic dome can often be analyzed to reflect this very 2:1 ratio, the architectural equivalent of a powerful foundational octave. Then there is the sweet, uplifting sound of a musical fifth, represented by the ratio of 3:2. This proportion might define the relationship between a chapel's length and its width, creating a space that feels both expansive and intimate. The slightly more reserved fourth, with its 4:3 ratio, could govern the dimensions of a soaring arch, its curve lifting your gaze heavenward in a silent, visual chord. This was not a loose metaphor, it was a precise architectural philosophy. The builders were, in effect, composing frozen music. When you walk through a space built with these proportions, your soul is meant to feel the same resolution and peace that your ear feels when it hears a perfect chord. The structure itself becomes a giant, silent instrument, tuned to the frequencies of the universe. This synthesis of sight and sound was designed for one ultimate purpose: to elevate the human spirit. In a world filled with earthly discord, the cathedral was a sanctuary of perfect harmony, a physical anchor point for the celestial order. It was a place where every stone, every arch, and every vault sang in silent chorus, aligning the worshipper not only with the geometry of the earth but with the very rhythm of the cosmos. Behind the soaring arches and luminous stained glass stood not solitary geniuses, but a hidden network of brotherhoods. These were the stonemason guilds, sworn fraternities who guarded their mathematical and architectural secrets with a fierce, almost sacred devotion. Their workshops were the true classrooms of this sacred science, places where young apprentices learned a craft that was far more than simple construction. Their training was a profound fusion of the practical and the mystical. They learned to wield the compass and the straightedge not just as tools, but as extensions of their own hands and minds. With these simple instruments, they could construct the entire universe of sacred geometry without a single number or written calculation. Every perfect circle, every proportional square, every triangle of divine ascent was drawn directly from these fundamental tools, embodying purity and precision. The master mason was more than a foreman. He was a spiritual guide and a living library of esoteric knowledge. He held the responsibility of interpreting divine principles, translating cosmic order into a tangible, mathematical form that could be understood by the human soul. This wisdom was not written in books that could be lost or burned. It was passed down through generations in an unbroken oral tradition and through symbolic drawings etched onto large, flat surfaces of plaster known as tracing floors. On these dusty canvases, the master mason would lay out the full-scale geometric patterns for a window, an arch, or an entire facade. These drawings were the true blueprints, intricate webs of circles and lines that contained the entire genetic code for the building. The secrecy of the guild was not about hoarding power, but about preserving the purity of a sacred language. By encoding their methods into the fabric of the buildings themselves, they created a permanent puzzle. The proportions of a pillar, the intersecting curves of a vault, the layout of a labyrinth on the floor, all of these were silent lessons left for those with the eyes to see. They built a library in stone, its shelves stretching toward the heavens, filled with volumes written in the language of geometry, waiting centuries for us to learn how to read them once more. These numerical codes transformed the very stones into a mystical alphabet. Beyond the flowing geometry of circles and ratios, specific whole numbers carried a weight of their own, acting as powerful symbols that conveyed entire theological doctrines. For a society where few could read written texts, the building itself became the book, and numbers were its most sacred chapters. The number 3, for instance, was far more than a digit. In the Christian worldview, it represented the Holy Trinity, the Father, the Son, and the Holy Spirit as one divine entity. This triune nature was physically carved into the fabric of countless cathedrals. You see it in the tripartite division of the floor plan, clearly separating the narthex, the nave, and the sanctuary, guiding the pilgrim on a 3-stage journey from the secular world toward the sacred altar. You pass through triple portals on the main facade, each archway inviting you into a different aspect of faith. Above, the triangular gables point skyward, a constant stone reminder of the 3 in one God. This repetition was a form of deep, subconscious instruction, reinforcing a core mystery of the faith with every glance. Equally potent was the number 7, a number echoing across cultures and linked to the 7 classical planets visible to the naked eye. It symbolized a complete cycle, spiritual perfection, and the steps of a soul's ascent. Walk through a great cathedral and you might find 7 radiating chapels encircling the ambulatory, each one a stopping point on a circular pilgrimage. A penitent might climb a flight of 7 steps to reach a high altar, each step representing a virtue to be mastered or a sin to be overcome. This number wove the cosmos directly into the ritual movement of the worshipper, making the building a map for both earthly devotion and celestial order. Then there was the number 12, the number of cosmic government and foundation. It called to mind the 12 tribes of Israel, the 12 apostles of Christ, and the 12 signs of the zodiac, bridging the Old Testament, the New Testament, and the natural world. This symbolism of a perfected community and divine order was set in stone through the layout of columns. A nave might be flanked by 6 columns on each side, together forming the number 12, a silent congregation of stone apostles supporting the vault of heaven above. A great rose window might be divided into 12 segments, its tracery framing the light that poured into the sacred space. Everywhere, the number spoke of a harmonious and complete system, a new Jerusalem built on a foundation of 12. This encoded language was a masterstroke of communication. For the learned clergy, the numbers represented complex theological ideas. For the illiterate farmer or merchant, the same numbers, repeated in portals, steps, and columns, conveyed the essence of those ideas through sheer, powerful presence. The 3 doors taught the Trinity without a single word. The 7 chapels charted a path to perfection without a written map. The 12 columns spoke of a unified church and an ordered cosmos without a lecture. This was the ultimate synthesis of faith and mathematics, where number became a direct conduit for the divine, a way to make the invisible truths of the Spirit visible, tangible, and unforgettable. Yet, this sacred mathematical language was not confined to the cathedrals of Europe. The same principles were whispering from the stones of temples half a world away, in traditions that had never met, yet somehow spoke the same universal tongue. This architectural revolution reached its zenith in the stone forests of the Gothic cathedral. Here, the sacred circle was fractured and reassembled into a new language of ascent, a geometry of pure light and weightlessness. The most iconic symbol of this style, the pointed arch, was far more than an aesthetic preference. It was a brilliant geometric solution born from the simple act of crossing two circles. A master mason would take his compass and draw two circles of the same size so that they overlapped. The area where they intersected created that sharp, graceful point. This single innovation changed everything. Unlike the rounded Romanesque arch, which pushed outward and downward with immense force, the pointed arch channeled its load more directly downward. This allowed builders to construct walls that were less like solid bulwarks and more like delicate cages of stone, with space for vast windows that flooded the interior with divine illumination. At the heart of this skeletal structure was the rib vault. Look up into the ceiling of a cathedral like Notre Dame de Paris before its fire, and you would see a network of stone ribs arcing through the air. These ribs formed a geometric skeleton, a web of intersecting arches that traced compound curves across the ceiling. This was not a solid shell of masonry. It was a framework, a triangulated structure that carried the weight of the roof along its specific, calculated lines. The spaces between the ribs could then be filled with thinner, lighter stone panels. The entire ceiling became a demonstration of geometric efficiency, a map of force distribution written in stone. But all that upward thrust from the soaring vaults had to go somewhere, and that is where the most dramatic innovation appears, the flying buttress. These magnificent, half-arching stone beams leap from the outside of the building like the roots of a colossal tree, anchoring themselves in massive piers. They are the externalized solution to an internal physics problem. The flying buttress performs a simple yet vital task. It catches the outward thrust from the roof vaults and channels it down through its own elegant curve, redirecting that immense force safely into the ground. At Cologne Cathedral, you can see a veritable forest of these stone flyers, a breathtaking exoskeleton that makes the hidden forces of physics visible. The entire structure becomes a dynamic equilibrium, a balance of push and counter-push, all calculated through geometric principles. The Gothic cathedral was, in its very essence, applied mathematics on a monumental scale. Every pointed arch was a function, every rib vault an equation, every flying buttress a proof. The builders were not merely constructing a church, they were solving a complex problem in structural engineering using the timeless language of geometry, all to create a space that would lift the human spirit right along with the stone. Across the world, in the shadow of the Himalayas, a different kind of sacred diagram was being drawn. While European masons worked with circles and triangles, the master architects of ancient India used a perfect square. This was the Vastu Purusha mandala, the cosmic blueprint for every Hindu temple. Imagine this not as a simple shape, but as a living, breathing entity. The diagram represents the body of a cosmic giant, the Purusha, pinned to the earth by the gods. His form is constrained within a square, and this square becomes the absolute boundary of the temple, a symbolic map of the entire ordered universe. This sacred square is then subdivided into a grid of smaller, perfect squares, like a spiritual chessboard. Each of these smaller squares is the domain of a specific deity or a cosmic force. The central squares are the most sacred, reserved for the primary god, like Brahma the creator, forming the temple's heart, the Garbhagriha or womb chamber. The outer squares are assigned to lesser gods and guardian spirits, creating a concentric hierarchy of divine power. The temple's entire layout, from the position of its walls to the location of its doorways and subsidiary shrines, is determined by this divine grid. Every element has its preordained place, creating a structure that is not merely built, but ceremonially born from this cosmological diagram. But this perfect order on the ground is only half the story. The temple's soul reaches for the heavens through its soaring tower, the Shikara. The design of this mountain-like spire follows a recursive geometric pattern, a principle of self-similarity. Each level of the tower is a smaller, proportional repetition of the one below it, creating a rhythmic, upward surge of stone. This is not random decoration, it is a visual mantra, a repeated mathematical formula symbolizing the soul's ascent through successive layers of consciousness toward ultimate unity with the divine. The entire structure, from its foundational mandala to its recursive peak, is a single, integrated mathematical equation. It is a machine for transcendence, built according to the same cosmic laws that govern the stars and the atoms. The parallel is stunning. On opposite sides of the globe, without any contact, human minds arrived at the same profound conclusion, that the universe is built on a foundation of mathematics, and that the most sacred duty of architecture is to mirror that divine arithmetic. This shared impulse raises a compelling question. If both the Gothic cathedral and the Hindu temple are expressions of the same universal language, what other echoes of this silent, geometric truth are waiting to be uncovered in the forgotten corners of the world? This pursuit of mathematical perfection has a birthplace, a temple so refined it seems to defy the very stone from which it is carved. High on the Athenian Acropolis, the Parthenon stands as a testament to a different kind of sacred geometry, one dedicated to human reason and optical mastery. Though it predates the medieval cathedrals by over 1,000 years, its architectural principles would echo through the ages. Its builders achieved something almost magical. They created a structure that looks perfectly straight and rigidly ordered, but is in fact a masterpiece of subtle curves and intentional imperfections. The massive platform on which the columns stand, the stylobate, is not a flat plane. It curves gently upward toward the center, a barely perceptible swell. If it were truly flat, our eyes would perceive it as sagging in the middle under the immense weight of the marble. By building in this subtle arc, the architects engineered an optical correction, creating the powerful, confident impression of perfect flatness. The columns themselves tell a similar story of visual calculus. Not a single one is completely vertical. They all lean inward ever so slightly, and if you were to extend their lines upward, they would eventually meet about a mile high in the sky. This slight inclination makes the temple appear more stable, as if it is firmly rooted and gathering itself against the forces of gravity. Even the columns have a life of their own. They swell gently in the middle, a feature called intosses, which prevents them from appearing pinched and weak, giving them the robust, muscular quality of a living being. This was not guesswork, it was a profound understanding of human perception, a visual calculus designed to please the soul as much as the eye. Guiding all these refinements were precise mathematical ratios. The facade of the Parthenon is a lesson in the golden ratio. The relationship between the height of the temple from the stylobate to the top of its pediment and its total width often aligns beautifully with this divine proportion. But an even more fundamental ratio governed the entire design, the ratio of 4:9. This proportion dictates the relationship between the temple's width and its length, and it repeats in the relationship between the diameter of the columns and the space between them. This 4:9 harmony creates a visual rhythm that feels both rational and deeply pleasing, a numerical foundation for its timeless beauty. The Greek mastery of proportion was a precursor, a brilliant flash of the same mathematical light that would later illuminate the medieval Mason lodges. It proves that this quest to build according to cosmic numbers is a thread woven through human history, connecting the intellect of classical antiquity with the spiritual fervor of the Gothic age. The silent language of mathematics was being spoken in marble long before it was whispered in stone. This celestial alignment was a science written in stone and shadow. Long before the term archaeoastronomy was coined, the master builders were practicing it, turning their temples into permanent observatories locked in a silent conversation with the sky. They understood that the universe was a clock of unimaginable precision, and they sought to synchronize their sacred spaces with its grandest cycles. A Christian church, for instance, was almost universally built on an east-west axis. The altar was placed in the east so that a congregation praying at dawn would be facing the rising sun, a powerful symbol of the resurrection and the light of Christ. This was not a vague directional preference. It was a precise alignment often calculated for a specific day, such as the feast day of the saint to whom the church was dedicated. On that morning, the dawn light would stream directly down the main aisle, striking the altar in a burst of celestial glory. But some ancient sites took this principle to an even more breathtaking extreme. Far older than the medieval cathedrals, the massive Neolithic tomb of Newgrange in Ireland stands as a testament to this ancient sky wisdom. This great circular mound, built over 5,000 years ago, contains a long, narrow passage leading to a central chamber. Above the entrance, a unique opening known as a roof box was constructed. For most of the year, the interior of this tomb lies in deep darkness, but for a few precious minutes around the winter solstice, at sunrise on the shortest day of the year, a narrow beam of sunlight pierces through this roof box. It travels down the long passageway, creeping silently across the floor until it dramatically illuminates the intricate spiral carvings in the deepest part of the chamber. This was a monumental feat of engineering and astronomical observation. The builders had to calculate the exact angle of the sun on the horizon for that specific day, and then construct a stone tunnel to capture its first light with pinpoint accuracy. They were encoding a message about rebirth and the return of the sun into the very landscape, creating a cosmic event that still occurs with reliable precision 5 millennia later. The mathematics behind such alignments had to account for a slow, grand celestial dance known as the precession of the equinoxes. This is a gradual wobble in the Earth's axis that completes a full cycle approximately every 26,000 years. Over centuries, this wobble causes the position of the rising sun on the equinox to shift very slightly against the backdrop of the stars. A temple aligned perfectly with a star like Sirius or the star cluster of the Pleiades would find its alignment slowly drifting over generations unless the builders understood this slow precessional drift. This means their astronomical knowledge was not just a snapshot in time. It was a deep understanding of cyclical time itself. They were building for the ages, designing structures that would remain in harmony with the cosmos not for a few years but for millennia. A stone circle, a pyramid, or a cathedral thus became more than a place of worship. It was a dynamic calendar, a cosmic clock, and a permanent anchor between the human world and the eternal rhythms of the heavens. This profound connection invites us to look up at the night sky and wonder what other cosmic conversations are still waiting to be heard in the silent stones of the ancient world. The ultimate challenge whispered among master masons was a puzzle that could never be solved. Squaring the circle represented the pinnacle of their sacred craft, a geometric quest to reconcile heaven and earth using only the pure tools of the compass and straightedge. The goal was to construct a square with the exact same area as a given circle. Mathematically, we now know this is impossible because it requires precisely constructing the transcendental number pi, which cannot be done with only those tools. But for the medieval mind, its impossibility was the entire point. It symbolized the greatest human aspiration to bridge the infinite, perfect realm of the divine, represented by the circle, with the finite, ordered, and material world of the square. This was not a failure of intellect but a profound spiritual exercise, a meditation on the relationship between the eternal and the temporal. The quest to make the celestial square able was an act of devotion in itself. You can witness this sublime reconciliation made stone in the great domed structures of the ancient world. Enter the Hagia Sophia in Istanbul. Your eye travels upward from the massive, square base, a symbol of the solid earth, to the majestic, floating dome that crowns it, a perfect representation of the heavens. The architectural genius lies in the transition. The builders used elegant triangular curves known as pendentives to gracefully resolve the tension between the square below and the circle above, creating a seamless fusion of both worlds. The same breathtaking synthesis defines the Roman Pantheon, where a vast circular coffered dome, an oculus open to the sky, rests with perfect equilibrium upon a cylindrical drum that is itself rooted in a square conceptual plan. These buildings are not just spaces, they are philosophical statements written in mortar and marble. To even attempt this geometric feat required brilliant approximations of pi. An ancient Egyptian document, the Rhind Papyrus, offered a practical formula, suggesting using a square whose side is 8/9 the diameter of the circle. This gives a value for pi of about 3.16, remarkably close for its time. Medieval masons used similar fractional shortcuts, like 22 divided by 7, to get close enough for their monumental purposes. The magic was not in achieving an unattainable perfection, but in the striving itself. Each stone cut, each arch raised was an act of faith, a declaration that the human spirit, guided by mathematics, could reach for the divine and, in the attempt, create something that itself felt divine. This endless quadrature of the cosmos stands as a testament to an age that saw no divide between the engineer and the mystic, where the compass in a mason's hand was a tool for touching the face of God. Light itself was a form of sacred masonry, carefully quarried and shaped by geometry. In the Gothic cathedral, the stone skeleton of pointed arches and flying buttresses performed a miraculous feat. It replaced solid walls with vast, luminous screens of colored glass. But this was not a simple act of opening up the building to the sun. The master builders were physicists of the soul, using precise mathematics to transform raw sunlight into a medium of divine revelation. The key to this transformation was the intricate stone tracery that held the glass in place. Look closely at a great rose window, and you will see its complex patterns of circles, arcs, and trefoils are not random decoration. This is a geometric diagram of the highest order, a structural web designed to bear immense weight while simultaneously fracturing the incoming light into 1,000 shimmering fragments. Each piece of stone acts as a prism, diffusing and softening the harshness of direct sunlight into a gentle, ethereal glow that fills the interior space. This calculated interplay of stone and light was tuned to the rhythms of worship. The angles of the window embrasures, the deep, splayed openings in the thick walls were not accidental. They were calculated to act as light scoops. During the winter solstice, when the sun hangs low in the sky, these angled openings would capture every precious ray of light, pulling it deep into the cathedral's nave. In the high summer, when the sun is directly overhead, the same geometry would shield the interior from excessive glare, maintaining a cool, serene atmosphere. This was a building breathing with the seasons, its relationship with the sun choreographed by silent geometric laws. The stained glass panels themselves were narrative mathematics. The stories of saints and prophets were not laid out like a simple comic strip. Their placement followed sacred geometric sequences, often based on the numbers 3, 7, or 12. A window depicting the life of Christ might be divided into 12 main scenes, mirroring the 12 apostles or the 12 hours of the day. Your eye is not meant to wander randomly. It is guided on a deliberate, symbolic journey from the bottom panels, representing the earthly realm, upward through the central mysteries of faith toward the topmost lancets that point toward heaven. The colors were part of this numerical code. The deep, costly blue of the Virgin Mary's robe, made from cobalt, might be positioned directly across from the radiant red of a martyr's passion, their complementary hues creating a visual harmony that echoed the musical intervals frozen in the architecture. This entire symphony of stone, glass, and light had one ultimate purpose: to create an atmosphere of transcendence. Standing in Chartres Cathedral as the afternoon sun strikes the west rose window, you are not merely looking at colored glass. You are witnessing geometry made luminous. The hard, rational lines of the tracery hold the liquid, emotional fire of the glass in a perfect balance, a manifestation of the medieval mind itself, where logic and faith were not opposites but two sides of a single, brilliant coin. The mathematics did not explain away the mystery. It became the very vehicle for experiencing it. This quest to encode cosmic truth was not confined to the grand cathedrals of Europe, however. The same principles echo in the silent, sun-drenched stones of the desert, where an entirely different civilization built its own mountains to the stars. The belief that a temple should mirror its creator runs far deeper than mere symbolism. This anthropomorphic vision of architecture was powerfully codified by the Roman engineer Vitruvius, whose ancient texts were rediscovered and revered in medieval scriptoria. He argued that sacred structures must emulate the proportions of the ideal human body, a form which nature itself has perfected. Vitruvius described a man whose outstretched limbs could touch both the circumference of a circle and the corners of a square, perfectly centered at the navel. This iconic image, later given immortal form by Leonardo da Vinci, was not just an artistic exercise. It was a philosophical bombshell, asserting that the human form is the ultimate measure of all things, a living bridge between the celestial perfection of the circle and the earthly order of the square. The medieval Masons absorbed this principle into their very bones. They saw humanity as created in the divine image, and therefore, a building based on human proportions would inherently reflect the geometry of the Creator. This was the ultimate divine blueprint. To translate this theory into stone, they needed a practical, universal standard. That standard became the 6-foot-tall man. Why 6 feet? It was a clean, whole number, easily divisible, and it represented a noble, idealized human scale. This 6-foot module became the fundamental unit of measure for entire cathedrals. The height of a column might be exactly 6 times this module, or 36 feet. The width of a bay in the nave could be 6 feet, creating a rhythm that felt instinctively right to anyone walking through it. Even the massive pillars were often designed with a diameter that was a simple fraction of this human module, ensuring they felt powerful but not monstrous, strong yet strangely familiar. This system ensured that every element, from the grandest arch to the smallest decorative detail, was part of a single, harmonious family of proportions. Stepping into a space built with these principles, you do not feel dwarfed or overwhelmed in a chaotic way. Instead, you feel a part of the structure. The scale is grand, but it is a grandeur that includes you, that makes you feel the building is an extension of your own body, magnified to a divine degree. The arches soar with a curve that echoes the reach of your own arms. The columns rise with the sturdy grace of a standing figure, and the light falls in patterns that guide you forward as naturally as a heartbeat. This was the genius of the Vitruvian ideal made real. It transformed cold stone into a warm, resonant shell for the human spirit, a space where worshippers could literally feel they were walking within a body designed by God himself. This profound connection between the microcosm of man and the macrocosm of the temple raises a humbling thought. If our sacred spaces were built in our own image, what does that say about our own potential for harmony, for balance, for touching both the earth and the heavens? Etched into the stone floor of Chartres Cathedral lies a path of profound simplicity and complexity. This is the Labyrinth, a sprawling circular design nearly 40 feet across that has guided footsteps for centuries. It is crucial to understand this is not a maze. A maze is a puzzle of branching paths and dead ends designed to confuse and test. The labyrinth offers a single, unbroken route, a universal path that winds and turns back on itself in an intricate pattern, yet always leads you forward, inevitably, toward the center. There are no wrong choices, only the commitment to the journey itself. This path was a substitute for a pilgrimage to Jerusalem, a spiritual voyage compressed into the sacred geometry of the cathedral floor. For those who could not undertake the perilous physical journey across continents, walking the labyrinth offered a way to make an interior pilgrimage, a journey of the soul. The design is a masterpiece of mathematical intention. Its classic 11-circuit pattern is constructed from a series of concentric circles, precisely divided and connected by a sequence of turns and arcs. The path does not spiral inward directly. Instead, it leads you on a long, meandering journey that takes you to within a few steps of the center, only to sweep you back out toward the periphery. You traverse every quadrant of the circle, experiencing the whole of the cosmos represented by the circular form, before you are finally allowed to enter the sacred center, the symbolic Jerusalem. This winding route is not random meandering. Its geometry often subtly incorporates the golden ratio and the Fibonacci sequence, creating a rhythm of turns that feels both organic and deeply ordered. The number of turns, the circuits, and the overall division of the circle all follow a precise, premeditated mathematical plan. To walk this path was to physically enact a spiritual equation. Each step was a form of moving meditation, a prayer made with the feet. The long, winding path toward the center represented a life of seeking, of penance, and of gradual purification. Reaching the center was a moment of enlightenment, of standing in the presence of the divine, but the journey was not complete there. You then had to turn around and walk back out, retracing your steps to re-enter the world, now carrying the peace and clarity gained at the center back into your daily life. The labyrinth is the ultimate metaphor for the hidden mathematics of the ancient world. It is a complex, beautiful, and purposeful design laid out in plain sight, yet its true depth is only revealed to those who choose to walk its path. It does not shout its secrets, it waits, a silent geometric poem, inviting the seeker to begin the journey of discovery. This winding stone path asks us a quiet question: how many other sacred equations are we walking over every day, unaware of the guidance they offer? While the Gothic architects sculpted light and the Hindu builders charted the cosmos on a square grid, another tradition was weaving the infinite from a single, perfect circle. In the courtyards of the great Mosque of Cordoba and on the facades of the Registan in Samarkand, you will not find images of people or animals. This aniconic tradition, avoiding figurative representation, unlocked a different dimension of sacred mathematics. It gave rise to a stunning visual language built entirely from geometry, a language of stars, polygons, and endlessly interlacing straps that dance across the walls. The creation of these patterns always begins with the same humble origin, a circle. A master artist would take a compass and divide the circle's circumference into 4, 5, 6, or more equal parts. By connecting these points with straight lines, they generated a universe of shapes, from simple squares and octagons to complex, multi-pointed stars. These fundamental shapes then become the tiles of a cosmic puzzle, fitting together in a perfect, gap-less tessellation that can theoretically repeat forever, covering any surface without beginning or end. This is where the deeper mathematics emerges. The patterns are governed by strict rules of symmetry, what mathematicians call symmetry groups. These rules dictate how a single motif can be rotated, reflected, and translated or slid to create the illusion of an endless, expanding field. Some patterns have a central point from which the design radiates in perfect 4, 6, or 8-fold symmetry. Others are based on a repeating band, a frieze pattern that could wrap around the world. The most complex are wall patterns that cover a flat plane in an infinite web, with no single point more important than any other. This creation relies on a principle known as recursion, where the same simple rule is applied over and over again. A basic star shape might be surrounded by a ring of polygons, and that entire cluster then becomes a new, more complex unit that repeats on a larger scale. It is a geometric echo, a pattern within a pattern, creating a depth that pulls your eye into a seemingly bottomless well of order. But why devote such immense intellectual and artistic effort to these abstract designs? The answer is profoundly theological. The endless repetition, the fact that you can follow a single line as it weaves in and out, disappearing and reappearing without ever starting or stopping, was a direct symbol for the infinite and omnipresent nature of God, or Allah. In a faith that emphasizes the absolute oneness and transcendence of the divine, these patterns became a perfect visual expression. They depict a universe that is not chaotic, but is instead underpinned by a constant, rational, and beautiful order, a direct reflection of a single creator. There are no loose ends in this sacred geometry, just as there are no accidents in divine creation. Every line, every intersection is part of a grand, coherent whole. To stand before the mihrab in a medieval mosque, surrounded by this shimmering field of mathematical devotion, is to experience a form of visual theology. The patterns are a silent, ceaseless recitation of the divine attributes, a meditation on eternity made visible. This was not mere decoration. It was a map of reality itself, drawn with the compass of faith and the straightedge of reason. It reveals a truth that echoes from the Gothic vault to the Hindu shrine, that the universe sings in the language of mathematics, and we have only to learn how to listen. The circle's perfect form presents a profound mathematical challenge, one that every builder of rotundas and domes had to confront. To construct a circular wall or a cylindrical drum, you must solve a riddle. How do you relate the straight line across a circle, its diameter, to the endlessly curving line of its circumference? The answer is pi, the irrational number approximately equal to 3.14159, with digits that continue forever without repeating. Medieval Masons did not have our modern decimal notation. Instead, they relied on brilliantly simple fractional approximations that were accurate enough for monumental construction. The most common was 22 divided by 7, which gives a value of about 3.1428, a difference of less than 1 part in 1,000 from the true value. Another method, attributed to the ancient Greek Archimedes, established bounds for pi, proving it was greater than 223 divided by 71 and less than 22 divided by 7. This gave the builders a reliable, bounded space in which to work. We can see this practical mathematics in action at the Church of the Holy Sepulchre in Jerusalem. The great rotunda enclosing the traditional site of Jesus' tomb has a diameter that measures approximately 21.5 meters. Historical analysis suggests the builders used a standard of 21 cubits. If they calculated the circumference using the approximation 22/7, multiplying the diameter by this fraction, they would have planned for a circumference of 66 cubits. The actual physical structure aligns closely with this calculation, a silent equation built in stone. The choice of pi was not merely a technical one. The circle itself was the ultimate symbol of eternity, having no beginning and no end. It represented the unity of God, the perfection of the heavens, and the infinite cycle of time. The mathematical nature of pi, an irrational and transcendental number, perfectly mirrored this spiritual concept. Its digits run on to infinity, defying any attempt to capture it completely in a finite fraction or decimal. Just as the human mind cannot fully comprehend the divine, it cannot fully capture the value of pi. Using 22/7 was an act of humility, a recognition that they were building an approximation of heavenly perfection here on earth. Every dome that echoed the vault of the sky, every rounded apse that housed an altar, was a testament to this dialogue between the practical and the eternal. The stone whispered a truth that every master mason knew, that in the struggle to measure the circle, they were measuring their own relationship with the infinite. This intellectual toolkit was not a random collection of subjects, but a unified path to wisdom known as the Quadrivium. It formed the essential curriculum for any master builder, the four mathematical arts that were the gateway to understanding the very fabric of creation. Before a mason ever lifted a chisel, he was expected to master this quartet of disciplines, for they were seen as different expressions of the same divine language. First was arithmetic, the study of pure number in the abstract. This was not mere counting, it was a philosophical exploration of the essence of numbers themselves. Why was 3 considered perfect and 7 sacred? Arithmetic explored the inherent properties and relationships of numbers, providing the symbolic vocabulary for the cosmic code. From this pure world of number sprang geometry, which is number realized in space. This was the practical application, where the abstract concepts of 3 or 7 were translated into triangles and heptagons, giving form and measure to the invisible ideas. Geometry was the tangible proof of numerical truth, the act of drawing heaven on earth with a compass and straightedge. The third art, music, introduced number in time. It explored the harmonic ratios that govern pleasing sounds, the same mathematical proportions that create a perfect fifth or a resonant octave. For the medieval scholar, this was not merely entertainment, it was audible evidence of a universal order. The same ratio of 3:2 that makes a chord sound beautiful in a chant was the very ratio that might define the proportions of a chapel, creating a space that felt harmonious to the soul. Finally, astronomy brought it all together, studying number in both space and time. It mapped the geometric paths of the planets and calculated the cyclical rhythms of the year, from solstices to equinoxes. This discipline provided the grand blueprint, the cosmic context into which every sacred building had to fit. A master of the Quadrivium did not see 4 separate subjects. He saw a single, luminous truth viewed through 4 different windows. Arithmetic gave him the sacred numbers, geometry taught him how to draw them, music revealed their harmonious relationships, and astronomy showed him where to place them in relation to the cosmos. When he designed a cathedral, he was not simply constructing a building, he was composing a symphony in stone, a silent oratorio built from number, form, harmony, and celestial alignment. This educational framework was the invisible foundation beneath every physical foundation stone. It equipped the architect with a holistic world view where every calculation was a prayer and every proportion a step closer to the mind of the divine. With this profound synthesis as their guide, these masters turned their attention to the very substance of their work, to the stone itself, which they believed held its own latent mathematical spirit waiting to be awakened. High on a sun-baked hill in southern Italy, a castle of pale gold stone defies all expectation. Castel del Monte, commissioned by the enigmatic Holy Roman Emperor Frederick II, is not a fortress of rounded towers and sprawling baileys. It is a perfect stark octagon, a geometric crown placed upon the landscape. Its entire design is a rigid mathematical puzzle, an obsession with the number 8 made manifest in limestone. 8 towering walls form the outer curtain. At each of the 8 corners stands an 8-sided tower. The central courtyard is an open octagon, and the main rooms are trapezoids carefully arranged around this 8-fold core. This is not a casual aesthetic choice. It is a relentless, sophisticated code. The octagon itself is a shape rich with esoteric meaning. For medieval thinkers, it represented a transitional state, a sacred threshold. It sits perfectly between the stable, earthly square and the infinite, heavenly circle, symbolizing the resurrection and the passage from the mortal world to the eternal one. Baptismal fonts were often octagonal for this very reason, marking the spiritual rebirth of the believer. Here, an entire castle is built as a font, a machine for transformation. But the geometry goes far beyond the static floor plan. The castle is a precise solar observatory. Specific windows and portals are angled so that sunlight pierces the interior at key moments of the year. On the equinoxes, beams of light would fall in perfect alignment through certain openings, illuminating designated spots on the floor with dramatic precision. During the solstices, other apertures would capture the sun's low or high angle, marking the turning points of the year within the castle's stone heart. These alignments turn inert stone into a dynamic calendar, synchronizing the emperor's residence with the cosmos itself. So what was its true purpose? It was too refined for a purely military role, too isolated and symbolic for a simple royal residence. Castel del Monte stands as a monumental riddle, a fusion of fortress, palace, and esoteric temple. It is a physical manifestation of Frederick II's own mind, a man deeply versed in mathematics, astronomy, and mystical traditions from both East and West. The castle's true secret is not hidden in a locked chamber, but in the very shape you see from a mile away. Its purpose is its geometry. It is a 3-dimensional theorem, a statement in stone that power, wisdom, and divinity are all expressed through the silent, unchanging language of number. What other royal commands are still waiting, not in dusty scrolls, but in the angles of the walls that surround us? The pentagram's 5 sharp points were far more than a mystical emblem. They formed a geometric key to understanding the universe itself. To construct a perfect pentagon, the medieval masons began with the golden ratio. If you draw a line divided so that the ratio of the whole line to the larger segment is the same as the larger segment to the smaller, you have the key proportion. By using this ratio as a step in their compass work, they could generate a 5-sided figure where every diagonal and side relates through phi. This self-replicating harmony, where pentagons spawn smaller pentagons infinitely, made the shape a symbol of life and cosmic order. It was seen as a diagram of the microcosm, with the 5 points representing the 4 classical elements: earth, air, fire, and water, crowned by the 5th, the spirit that animates them all. This is why the Pythagoreans, centuries earlier, had revered the pentagram as a sign of perfection and used it as a secret symbol of recognition. The master builders inherited this deep, symbolic mathematics and encoded it directly into their structures. Certain churches, like the Carolingian chapel in Aachen, are laid out on an octagonal plan that subtly incorporates pentagonal geometry in the relationships between its levels and supports. Look at the ground plan of a castle like the French Château de Chambord from above, and some historians argue you can trace a pentagram in the arrangement of its central keep and outlying towers. This was not an invocation of magic in the popular sense, but a profound statement of belief. By embedding the pentagram into a chapel or a fortress, the builders were declaring that this place was in harmony with the fundamental patterns of creation, from the human body with its 5 extremities to the very cosmos it reflected. They used one of the most complex geometric constructions possible to express a simple, powerful truth: that the same divine mathematics that shapes a tiny seed also shapes a sacred space. This mathematical harmony echoed from the blueprint to the quarry, where a simple secret enabled the construction of stone giants with astonishing speed. Master builders achieved this not through chaos, but through a rigorous system of modular design and standardization. At the heart of every project lay a single, fundamental unit of measurement, the module. This was often a length derived directly from the human body, such as the foot, the span of a hand, or the royal cubit, the distance from the elbow to the tip of the middle finger. This human scale module became the DNA for the entire structure. Once the master mason established this base unit, every other dimension was generated by multiplying or subdividing it using simple whole number ratios. The height of a column might be 6 modules, the width of a bay 3 modules, and the thickness of a wall half a module. This created an unbreakable family of proportions, ensuring that every stone, from the smallest block in the foundation to the most ornate carving on a spire, was part of a single, cohesive mathematical whole. This modular system was brought to life through 2 powerful geometric progressions. The first was known as ad quadratum, meaning by the square. A master mason would begin with a single square drawn on his tracing floor. By drawing a diagonal across that square, he could use that length to generate a second, larger square. Rotating this new square 45 degrees created an octagon, and the process could be repeated, scaling the design upward in a cascade of perfectly related squares and octagons. This progression naturally incorporates the square root of 2, allowing for rapid and precise scaling of entire floor plans and tower bases. The second method was ad triangulum, or by the triangle. Starting with an equilateral triangle, builders could use its inherent geometry to generate a perfect hexagon, and from there, a 12-sided figure. This triangular progression was the geometric engine behind the complex, multifaceted designs of apses, vaults, and the intricate tracery of rose windows. With just a compass and a straightedge, a master mason could scale an entire cathedral from a single, small diagram. This was pre-industrial mass production in its most elegant form. Hundreds of workers, spread across distant quarries and noisy workshops, could all work in perfect coordination because they all adhered to the same module. Stone blocks were prefabricated to specific modular dimensions, their faces carved with such precision that they could be fitted together with a hair's breadth of mortar. The stonecutters did not need to understand the grand theological vision. They simply had to follow the numbered templates and cut stones to the prescribed module. This underlying mathematical consistency meant that when the stones arrived at the building site, often after months of work, they would lock together like a colossal, 3-dimensional puzzle. A single, repeated unit of measure, multiplied and divided by sacred ratios, allowed 1,000 hands to act as one, raising a symphony of stone from a foundation of pure, silent number. But the stone giants could not speak their secrets forever. The very world that built them began to turn away, its priorities shifting from the heavens to the earth. The Renaissance dawned with a new focus on humanism, celebrating the individual artist and the rediscovered beauty of classical forms. The compass and the straightedge, tools of cosmic alignment, were slowly set aside in favor of the drafting table and the personal sketchbook. The architect was no longer a master mason interpreting divine law, but an individual genius imposing his own vision. This philosophical shift was catastrophic for the old traditions. The tightly knit Mason guilds, the sworn brotherhoods who had orally safeguarded the sacred codes for centuries, began to dissolve. Their workshops closed, and their tracing floors were swept clean for the last time. The language of number and symbol, once the bedrock of sacred construction, faded into obscurity, replaced by a new vocabulary of purely aesthetic and human-centered design. By the time the Industrial Revolution arrived, architecture had become a matter of function and efficiency. Buildings were engineered for profit and utility, their forms dictated by steel beams and concrete, not by the golden ratio or the music of the spheres. The very idea that a structure could contain a hidden mathematical sermon seemed like a quaint superstition from a forgotten age. The codes were not destroyed, they were simply no longer understood. Yet a few curious minds refused to let the silence become permanent. In the 19th century, as Gothic cathedrals crumbled from neglect, architects like Augustus Pugin looked upon them with fresh eyes. He saw not just decaying stone, but a lost system of profound belief and intelligence. Pugin became a passionate revivalist, meticulously documenting the proportions and symbols of medieval buildings, arguing that their beauty was a direct result of their spiritual integrity. He began the painstaking work of deciphering the geometric palimpsest, reminding the world that these structures were more than just pretty ruins. The rediscovery gained momentum in the 20th century with the work of enigmatic scholars like R. A. Schwaller de Lubic's. He spent years studying the Temple of Luxor in Egypt, concluding that every dimension, every statue, every hieroglyph was part of a conscious, unified system of sacred science. He argued that the ancient Egyptians used a sophisticated canon of proportions, a philosophy of number that saw the temple as a living, growing organism, built in the image of both the cosmos and the human body. His ideas, though controversial, repopularized the notion that the ancient world possessed a deep, encoded wisdom. This journey from obscurity to rediscovery makes our modern understanding all the more precious. We are not just restoring old buildings, we are relearning a lost language. The fact that these principles had to be rescued from the brink of oblivion invites a haunting question. What other profound truths have we paved over in our rush toward a purely functional world? The silent mathematics of the master builders is finally finding its voice. We are no longer limited to measuring tapes and educated guesses. A technological renaissance is sweeping through these ancient sites, armed with tools that see through stone and map reality with sub-millimeter precision. Three-dimensional laser scanners now cast a web of laser points over every surface of a cathedral, from the worn steps of the Labyrinth to the highest gargoyle. In a matter of hours, they capture billions of data points, creating a perfect digital twin of the structure. This point cloud data reveals the building not as a perfect, idealized drawing, but as a living, breathing entity that has settled and shifted over centuries. We can now measure the subtle inward lean of a column with an accuracy the original masons could only dream of, confirming their intentional optical refinements. Alongside this, photogrammetry stitches together thousands of high-resolution photographs, wrapping the laser-scanned skeleton in a skin of photorealistic texture. This allows us to see the wear patterns on the stone, to analyze the fading pigments in the carvings, and to understand how light interacts with the architecture at a microscopic level. Suddenly, the building's entire life story is laid bare in a digital archive, but the revelations do not stop at the surface. Ground-penetrating radar sends pulses of energy deep into the earth, unveiling the hidden anatomy beneath our feet. It maps out forgotten crypts, the foundations of earlier structures, and even the geological composition of the bedrock. This technology can show us the precise layout of a temple's foundational trenches, revealing if the initial square was laid out with a specific geometric sequence, like the ad quadratum method, before a single stone was set. With these immense, hyper-accurate digital models, computational analysis can begin its true work. Researchers can run thousands of simulations in minutes, testing theories about proportional systems on a scale that was once impossible. Was the floor plan truly based on the golden ratio? The computer can analyze every possible dimension, calculating ratios and comparing them to sacred constants with objective, unwavering logic. It can test celestial alignment theories with astronomical software, rewinding the sky not just to the year of the temple's consecration, but across millennia, to see if its windows and portals align with the specific stars rising from 5,000 years ago. This digital proof is confirming many long-held intuitions. The recurring presence of the square root of 2 in Cistercian abbey plans is no longer a suggestion, it is a statistical certainty. Yet the technology is also uncovering a subtler, more profound layer of genius. We are discovering that the builders often employed multiple, overlapping proportional systems within a single structure. A nave might follow one geometric progression based on the square, while the choir adheres to another based on the pentagon, with both systems harmoniously integrated at the crossing. These are not simple, one-note designs. They are complex fugues of mathematical thought, woven together with a sophistication we are only now beginning to appreciate. The master builders were not just applying a formula, they were composing a symphony in 3 dimensions, and our newest instruments are finally allowing us to hear every note. A shared mathematical whisper echoes across continents and centuries, from the ribbed vaults of Chartres to the recursive towers of Khajuraho. The same sacred numbers appear again and again, as if humanity was independently discovering a single, universal language. The golden ratio, phi, governs the spiral of a nautilus shell and the curve of a sunflower, but it also defines the floor plan of a Gothic cathedral and the precise proportions of the Parthenon. The square root of 2, a number born from the diagonal of a square, gave structural rhythm to Cistercian cloisters in France and dictated the expansive, self-replicating rectangles of temple mandalas in India. And the endless, irrational number pi, used to measure the circle, allowed builders in Jerusalem to construct the rotunda of the Holy Sepulchre and guided the Aztecs in aligning their pyramidal Templo Mayor with celestial cycles. These were not different languages, but different dialects of the same cosmic tongue. This shared vocabulary extended to the grandest architectural gestures. The squaring of the circle, that impossible geometric quest to reconcile the finite earth with the infinite heavens, was not just a European obsession. The Hindu temple, with its square mandala base reaching for a circular peak in the Shikhara tower, sought the same synthesis. The great stupas of Buddhism, like Sanchai in India, are hemispherical domes representing the cosmos, often built upon a square platform or surrounded by a square railing, symbolizing the earthly realm. This same profound reconciliation of circle and square is physically manifested in the Roman pantheon and conceptually encoded in the layout of Mayan ceremonial centers, where circular astronomical observatories were integrated into vast quadrangular plazas. The drive to unite heaven and earth in a single geometric form was a global phenomenon. Even the alignment with the stars reveals a common purpose. The Christian Church oriented its altar to the east, capturing the resurrection light of the dawn. Half a world away, the Pyramid of the Sun at Teotihuacan is precisely aligned with the setting sun on specific dates, its massive form a calendar in stone. The Great Mosque of Janeh in Mali is oriented so that its Qibla wall faces Mecca, a spiritual alignment as precise as any astronomical one, and the Angkor Wat complex in Cambodia was designed so that during the spring equinox, the rising sun crests directly over its central lotus tower, a spectacular event engineered into its very foundations. Each culture looked to the same sky and heard the same call to build their world in harmony with the cosmos. What does this astonishing convergence mean? It suggests that the human mind, when contemplating the divine and the nature of reality, naturally arrives at the same mathematical truths. This was not a conspiracy of secret knowledge passed between civilizations. It was an intuitive recognition of a fundamental order, a collective human understanding that the universe is built on a scaffold of geometry and number. The medieval mason, the Vastu Shastra priest, and the Mayan astronomer were all reading from the same grand blueprint, written not on parchment, but in the very fabric of space, time, and form. They were all using the same silent language to ask the same eternal questions and to build their answers in stone, a permanent testament to our shared quest for meaning in a beautifully ordered cosmos. These ancient mathematical whispers did not fade with the stone giants. They found new voices in the modern world, their principles echoing in the steel and glass of contemporary design. The Swiss architect Le Corbusier became a direct bridge between eras when he developed his modular system in the 1940s. This was a bold attempt to create a universal standard of proportion based on the human form, a direct descendant of the Vitruvian ideal. Le Corbusier's modular man, arm raised, was inscribed with a double scale of measurements, all derived from the golden ratio and the Fibonacci sequence. He used this system to design everything from apartment buildings to an entire city, believing that spaces scaled to human mathematics would foster harmony and well-being. His Unité de Habitation in Marseille stands as a concrete testament to this belief. Its facade and interior lay out meticulously following the modular's rhythmic proportions. This was not a nostalgic revival. It was a conscious effort to reclaim the ancient understanding that our environment should resonate with the same numerical order inherent in our own bodies. Modern spiritual architecture continues this sacred conversation. Walk into Tadao Ando's Church of the Light in Japan, and you are enveloped by a profound geometry of pure forms. A stark concrete box is split by a cruciform slit in the wall behind the altar. The placement of this cross is not arbitrary. Its proportions and the resulting play of light are calculated with a silent, mathematical rigor that creates an atmosphere of intense meditation. The entire space feels like a single, resonant chord, a modern chapel built on the same principles of harmonic proportion that guided the medieval masons. The concept of fractal geometry, formally defined by mathematician Benoit Mandelbrot in the 1970s, gives us a new vocabulary for an ancient pattern. Fractals are shapes that display self-similarity, where the same pattern repeats at different scales, from the vast branching of a tree down to the microscopic veins of a leaf. This is the same recursive principle you see in the stone lace of a Gothic rose window, where a large pointed arch contains smaller arches, which in turn hold even smaller ones. It is the same logic that governs the infinite expansion of an Islamic star pattern. Modern architects now use fractal algorithms to design buildings that feel organically complex and deeply rooted, like the swirling, shell-like forms of certain concert halls, whose surfaces are engineered for perfect acoustics through mathematical repetition. The legacy of the temple builders is not locked in history books. It lives every time an architect chooses a proportion not for mere aesthetics, but for the silent harmony it creates within the human spirit. We are rediscovering that beauty, function, and a sense of the sacred are not separate goals. They are the natural products of a deep, underlying mathematical order, a universal language we are only beginning to speak fluently once more. These stone giants stand as a permanent testament to a universal human truth. Our ancestors did not see mathematics as a cold, abstract science, but as a living, sacred language for conversing with the cosmos. In the silent sermon of a cathedral's vault, in the celestial alignment of a desert temple, and in the infinite patterns of a mosque's wall, they encoded a profound understanding. They recognized that the same golden ratio that shapes a seashell should shape a sacred space, that the same harmonic intervals that please the ear should govern architectural proportions, and that the same stars that rule the heavens should guide the placement of a cornerstone. These structures are far more than artistic monuments or feats of engineering. They are libraries of knowledge written in the vocabulary of geometry, number, and light. Each one is a permanent dialogue between heaven and earth, a bridge connecting faith and reason, art and science, the human spirit and the infinite. This journey through their hidden codes invites us to see our own world with new eyes. Look at the spiral of a pine cone, the branching of a tree, or the pattern of veins in a leaf. The same sacred mathematics is at work, whispering the same ancient truths. The legacy of the master builders is all around us, not just in stone, but in the very fabric of nature. It reminds us that we are part of a beautifully ordered cosmos, and that the quest for harmony is written into our very being. If this exploration into the intersection of mathematics, history, and mystery has captivated you, we would love to hear your thoughts in the comments. Your curiosity fuels these deep dives into the secrets of our